So finally, for the last question, question 5, we've got a rectangular hyperbola question. We have the equation xy is equal to 25, and we have to work out a few things regarding this equation. So we have to find the equation of the line T1, which is given here. We have to write an equation for the line T2, which is just a little follow-on from part A. And then finally for part C, we have to find the coordinates of intersection for the lines T1 and T2. So let's have a go at doing this. It's actually not too bad of a question. It's quite a nice end. Question 5. So for part A, I think there's a couple of ways of doing it. Well, I know there's a couple of ways of doing it. The way I prefer to do these questions is to write your equation as y equals. So if it's xy is equal to 25, that means y is equal to 25 divided by x, right? 25 over x, like that. Now we need to differentiate it. So dy by dx, so the differential, that's going to give me minus 25 over x squared. I'm just differentiating this equation here. So 25 over x squared. And we know the points, or what would be my x here, is 5t, right? So let's just put that where the x is. So that's going to give me minus 25 divided by x squared. So what's that going to be? So that's going to be 5t all squared. 5t all squared, like that, outside the bracket. So simplifying that, you're going to get minus 25 divided by 25t squared. It's going to be 25t squared. So what that actually gives us is minus 1 over t squared. So the gradient at this point is minus 1 over t squared when we're working with 5t. That's the x coordinate here. That's what it was there. We subbed it in, we've simplified the expression to get minus 1 over t squared. Now, because this is the equation of a tangent, the tangent to r, we don't need to worry about, finding the negative reciprocal. This is absolutely fine at this point. All we need to do now is just work out the equation of the, the straight line here. Well, not the straight line, sorry, but the equation of the line. So that's going to give me y minus y1. So that's going to be y minus 5 over t. As we're subbing in now, our y coordinates, that's 5t to the minus 1, so that's 5 over t. That's going to be equal to minus 1 over t squared. Minus 1 over t squared. X minus x1, so that's going to be my 5t. X minus 5t. From here now, the easiest way to simplify this is to times through by t squared. So if we times this side by t squared, all that's going to happen is this denominator of t squared will just disappear. This side, so I'm going to get t squared y minus, that's going to be 5t. If you times through by t squared, you just get 5t. And this is going to be equal to minus x plus 5t. We're nearly there now. As you can see, we're very close to getting in this rearranged form here. All I need to do now is add the 5t onto this side. That'll give me my 10t. And take the x across to give me plus x, and then we've got it. So this is t squared y plus x is equal to 10t. Perfect. That's the first 4 marks. Nice and easy. So that's that part done. Part B, just a dead quick follow-on. It says the point Q, which is this, and if you notice, it's very, very similar to this. In fact, it is nearly identical, but instead of t, we've got s, right? This also lines on R, where t is not equal to s. The tangent to R at Q is the line T2. Write down an equation for the line T2. So as you can see, it's only 1 mark. It has to be nice and easy. And the way to see what's going on here is just think about what's happening. So it's a tangent again. And all that's changed is the letter S. So where you've got a T, all that's going to happen now is it's going to be an S, right? That's all that's changing. So all we've got is S squared y plus x is equal to 10s. Nice and easy. Job done. Because if you was to do this question again, but with an s, you'd get this exact same thing, but with the s. That's all that's happened here. But because it's the exact same style, the exact same numbers and such, we don't even need to work it out. We can just replace the t's with the s's. And that's part B done. And then finally, for part C, what have we got here? So we have to find the coordinates of intersection. So what you've got here now is 2 simultaneous equations, right? We've got t squared y plus x equals 10t, s squared y plus x equal to 10s. So what would I get if I was to subtract both these lines? So what I'd actually get would be t squared y minus s squared y. So that'd be t squared y minus s squared y. And that's going to be equal to 10t minus 10s. That's going to be equal to 10t minus 10s. As you can see now, we've got things we can factor on both sides. So I'm going to factor a t and a y out here, sorry, and then I'm going to factor my t out on this side. So, but I'm factoring this up a little. Ignore me. We're going to factor out the y here, but we're going to factor out the 10 here. So let's just go through that. That's going to be y equals. What I'm going to do is I'm going to skip the step where I factor out here. I'm going to just put it as the denominator, because obviously if I factor it out here, I can then divide through. So what that's going to give me, it's going to be 10 lots, because we're factoring the 10 out, of t. Oh, sorry. I'm going to say I'm confused myself. Blah, blah, blah. This should actually be an s. What I'm going to do, I'm just going to change that to an s. That's an s. I confused myself now. I was kind of thinking, how does this even possible? Yeah, all right, okay. So we're on the right path. We factor out the 10. So it's going to be t minus s. And then we divide through by what we factored out here. So that's going to be divided by t squared minus y squared. And that's our y coordinate. That's that part done. We're nearly done. What we're going to do, though, is we need it in its simplest form. So we're going to factor here. If you notice, this is the difference of two squares. So this is t squared minus y squared. So that's going to give me 10 lots of t minus s divided by, that's going to be t minus s times t plus s. Notice we can cancel that with that to give us 10 over t plus s. And that's that part done. So we've got the y coordinate now. All we need now is the x coordinate. And the x coordinate's a bit easier. If I just draw a line underneath here. For the x coordinate, what we need to do now is think of the rearrange. So this would be x is equal to 10s minus s squared y. So x is equal to 10s minus s squared y. So minus s squared. Notice our y, this is our y coordinate. So this is what we're replacing here. 10 divided by t plus s. So divided by t plus s, what's that going to give me? So the easiest way to do this is to expand this out. So that's going to give me 10s squared divided by t plus s. And then we're going to multiply this by t plus s, the denominator here. So what we're going to get next is x equals 10s times by t plus s minus 10 squared. 10s squared even. My brain's not working today, sorry guys. And this is all going to be divided by t plus s. If we simplify this now, I'm going to get 10st. So it's going to be 10st plus 10s squared and then minus the 10s squared, so minus 10s squared. I'm running out of room here, this is not well prepared, but divided by t plus s. Sorry about that, guys. So this is going to be t plus s on the denominator. So if you cancel this down now, that's going to be 10st, because obviously that 10s squared here will cancel with the minus 10s squared. You just perform the, the subtraction. So that's going to give me 10st divided by t plus s. And we've done it, that's our x coordinate. So we find the coordinates of the intersection of the lines T1 and T2 in their simplest form. And that's the full paper done. So hopefully it's been helpful, guys. If it's definitely helped, be sure to subscribe. I'm doing all these papers. Pretty much everything but mechanics, because I don't like mechanics. So everything else, be sure to check out. They're in the channel and description below.